Hello, my name is Joe Romanyk, and this is my CE 570 Project 3 Scalar Vector and Tensor Fields. So for my project, I chose to model a double T beam as shown in the top, and we're going to model it under simply supported and distributed load. So the objectives of this project was to define a scalar field, a vector field, and a tensor field on a 3D body. So to define our body, we define our body as three rectangular cuboids with varying dimensions depending on which body part they are. So for example, body 1 is our top slab portion, which has dimensions in the x1, x2, x3 of 0 to 10, 0 to 6, and 1 to 2. For our two bottom pieces, the x1 directions are 0 to 10, and the x3 directions are 0 to 1. And then for their x2 directions, they both have a width of 0, one starting at from 1 to 2, and the other going from 4 to 5. For our scalar field, I chose to plot just the potential energy of the material for our double T beam. And so as you can see, as we go up in the beam, or in our double T, we increase the potential energy for our scalar field. For our tensor field, I chose to do a symmetric matrix with the diagonal columns being x1, x2, and x3, and with the off diagonals just being 0. And this resulted in a tensor field shown on the left where we get an increasing value as x, y, and z all get larger. And this is shown with the transition from bluish purple all the way to yellow in the top right corner. So next, after defining a tensor, we wanted to define our vector field. And for this, we wanted to model a simply supported beam under a distributed load. So here we have x1, x2, x3 with zeros for the first two, and then our last one will be our x3 direction, and we define a parabola with zeros at 0 and 10, and I'll have a maximum at the midspan of our beam, which is at x1 equals 5. And so here we can see that our displacement at the ends is 0, and then we have our maximum displacement under our load or our vector field at x equals 5. Once we have defined our tensor T and our vector field, we began to look at how the tensor would affect our vector field at a given point. So after calculating our total volume, we looked at the point 532, which is the center of our beam at the top of our body part 1, which is our slab. And we got our vector u being 0, 0, -1. Our tensor T, which we said was in our diagonal columns, was just our x1, x2, and x3 point. So we got 5, 3, and 2. And then our vector u prime, which is equal to our vector u acted on by tensor T, we ended up getting 0, 0, -2. We can see that our MATLAB calculations were exactly the same as our hand calculations, which is good. On this slide, we can see the hand calculations done for calculating our volume of our object and calculating the vector u prime, which is the vector u acted on by the tensor T. Thank you for watching my Project 3 for CE 570.